Assalamualaikum warahmatullahi wabarakatuh and a very good day to my respectful panel. My name is Farhana Binti Shahabuddin with metric number AN190006. My beloved supervisor is Technologist Dr. Siti Aisyah binti Mansor. In regard for today's presentation, I would like to present a proposal of my bachelor degree project entitled Microencapsulation Efficiency and Thermal Stability Study of Encapsulated Vibrate Bioactive Compound using CHITOSAN and Arabic gum generated by spray drying process. Throughout my studies, a guided outline had been created in order to complete the project. From the presentation, it will include with introduction, literature review, methodology, expected result, as well as conclusion. A table of Gantt chart are also included at the end of the slide. Without further ado, let us continue to introduction. In this, the first part of my introduction will be covered on research background. The information of the research will be explained from broad to detailed order. Nowadays, there has been an increased interest in finding natural functional substances with high nutritional content and most importantly, can provide positive health impacts. Beverage is one of the byproducts and it has been considered as functional product for human intake since it has a variety of nutritional benefit as well as bioactive components that have therapeutic or preventative properties. For example, the therapeutic effects such as antibacterial, antidiabetic, anti-cancer, and antioxidant characteristics that makes beverage beneficial for human health. Moving on to the next point, microencapsulation is a physical technique in which the active component is encapsulated. Microencapsulation also a procedure by which bioactive compound is coated with polymer that protects them from external influences and enable for the controlled release of active bioactive compound. The main function of microencapsulation is to protect the beverage bioactive compound. The pharmacological activity of bioactive compound could be preserved and their storage time can be extended through microencapsulation. Microencapsulation could be done by using food-grade polymer. CHITOSAN and Arabic gum are examples of food-grade polymer that can be used to encapsulate the beverage bioactive compound. These two food-grade polymer can protect the bioactive compound from the surrounding condition, namely as pH, humidity, and normal metabolism. Due to their capacity to form film, viscosity, and resistance to gastrointestinal tract, solid content, biodegradability, safety, and low cost, these two polymers are appropriate for microencapsulation. Microencapsulation can be done by using spray drying process. Spray drying is a highly successful and commonly utilized encapsulation process in the food and pharmaceutical industries. Before the beverage undergo spray drying, the beverage must undergo emulsification first. Emulsification is the process of dispersing one liquid containing the bioactive compound in a second immiscible liquid by electrostatic, hydrophobic, or hydrogen bonding interaction between the bioactive chemicals and an encapsulating material. As I had explained before, the beverage is one of the byproducts that contain the properties such as antioxidant, antimicrobial, anti-cancer that give benefit to human health. However, the research on this beverage is limited and underexplored. Hence, this study is conducted to explore the benefit of beverage that give beneficial for human health. Next, the current preservation of beverage is using conventional technique, such as the beverage is being placed in the refrigerator or in the freezer. The current technique lead to high moisture content in the beverage. As a result, the high moisture content in the beverage could promote the growth of the bacteria. This will make the beverage is not durable for a long period of time. Hence, the beverage should be dried by using spray drying process. Drying the beverage using spray drying requires a high temperature. This high temperature could degrade the beverage bioactive compound. Therefore, encapsulation is needed to protect the beverage bioactive compound. In addition, the beverage is consumed orally. Without encapsulation, the bioavailability of beverage is reduced. Hence, encapsulation is needed to protect the beverage bioactive compound as well as to increase the bioavailability bioactive compound. Next, the objective could be concluded as follows. For the first part, to encapsulate vibrate bioactive compound with chitosan and Arabic gum by using spray drying method. Second, to compare the antioxidant capacity of encapsulated bioactive compound by the PPH radical scavenging assay and ferric antioxidant power FRAP assay. And the last one, to determine the thermostability profile of microencapsulated by spray drying of bioactive compound when subjected to accelerated heat. Next, the scope of study is as follows. The first one, vibrate is collected from Nyaleh Trigona farm, which is located in Malacca. Next, the microencapsulation is done by using fruit gate polymer, which are chitosan and Arabic gum, by using spray drying method. Third, the microstructure of particle in the vibrate bioactive compound, which encapsulated with chitosan and Arabic gum, will be identified using scanning electron microscope (SEM). Total phenolic content and total flavonoid content are used to estimate the microencapsulation efficiency of the vibrate bioactive compound. Identification of antioxidant capacity is done by the PPH radical scavenging assay and ferric antioxidant power FRAP assay. Next, TGA, TSC are used to examine the thermostability of encapsulated bioactive compound in the vibrate, while FTIR are used to examine the degradation of the vibrate bioactive compound before and after. Next, for literature review, we will start with the species of bee that is used in this research. In this research, the bee breed will be produced by Heterotrigona itama. Heterotrigona itama is one of the stingless bee species. It is the members of the Apidae family group cited by Hanum 2016. It is simple to construct an artificial hive in order to manage the colony and to increase the honey output. The main reason chosen for this bee is it do not sting. Honey, bee pollen, propolis, royal jelly, and bee bread are some examples of the bee product. However, the study will focus more on bee bread. There are many compositions of bee bread. For example, water, protein, amino acid, lipid, fatty acid, carbohydrate, vitamin, mineral, polyphenic composition, and enzyme are some examples of the composition of the bee bread. In this study, we will focus more on two benefits of bee bread. The first benefit of bee bread is antioxidant. Antioxidant is used to eliminate or remove the overproduction of free radical, also known as reactive oxygen species, ROS, that will cause molecular damage to DNA, protein, and lipid, cited by Muhammad et al. 2021. Next, the next benefit of bee bread is it will act as antimicrobial. It will against bacteria, yeast, and parasites. There are three types of polymer. The first one is natural polymer, synthetic polymer, and the last one is semi-synthetic polymer. In this research, we encapsulate the bee bread by using fruit gate polymer. Fruit gate polymer is example of natural polymer. The definition of natural polymer, it can be produced naturally, mostly in plants and animals. Synthetic polymer is created in laboratory through the polymerization of simple chemical compound. Fruit gate polymer are chosen in this industry because of their advantages such as abundant and renewable, water solubility enhancer, biodegradable, non-toxic, and biocompatible, compared to synthetic polymer and semi-synthetic polymer. Encapsulation method can be described as the process of entrapping one substance inside another, according to Guo et al. 2020. Coercivation method, co-crystallization method, extrusion method, emulsion method are examples of encapsulation method. And the last one is drying technique. The main feature of this approach is that it minimizes the amount of water in the food, which helps to prevent or delay food spoilage caused by microorganisms, cited by Shilpa et al. 2019. Sun drying, fluidized bed drying, freeze drying, spray drying, microwave vacuum drying, infrared drying is example of drying technique. This presentation will be continued with methodology. The bibred bioactive compound will be encapsulated by using spray drying process. Before spray drying process can be done, the formulation of emulsion need to be prepared first. There are 4 samples that need to be prepared. The first one is bibred without any polymers, bibred with CHITOSAN in 1:1 ratio, bibred with Arabic gum in 1:1 ratio, and bibred with mixture of both Arabic and CHITOSAN. The formulation is done to identify which formulation of this sample are capable to effectively encapsulate the bioactive ingredient in bibred. And next, the microencapsulation by spray drying, according to Jayu et al. 2020, is done. The microencapsulation is used to produce a dry powder form of bibred with using a hot gas. A microstructure of particle using SEM also done to visualize the bioactive compound in microencapsulated bibred by using scanning electron microscope, Joule, Japan. Next, microencapsulation efficiency by using Raka and Orena 2020. The microencapsulation efficiency can be tested using flavonoid test and phenolic test. Flavonoid test is done to evaluate the relationship between the availability of flavonoid and their contribution to a bibred antioxidant capacity. Phenolic test was done based on the previous study done by Ailang et al. 2021 with slight modification. Next, moving on to antioxidant capacity of microencapsulated bibred. This could be done by using DPPH assay and FRAP assay. These two methods are done by using the Zaida et al. 2019 with slight modification. And last one, for evaluation of thermal stability under accelerated condition, TGA is used to analyze the thermal analysis. DSC is used for polymer characterization, while the degradation of polymer are being tested using Fourier transform infrared spectroscopy or FTIR, cited by Ansarifar et al. 2017. Figure 1 shows the flowchart of this research methodology, as I had explained before. And next, we will move to expected result. In expected result, the microencapsulation by spray drying process will be conducted successfully. Next, when visualize the microstructure of bibred bioactive compound using SEM, the morphology of microencapsulated bibred surface should be smooth with few fissures, irregularities, and roughness for microparticle in order to promote effective encapsulation potency for better defense of main constituents. Next, a microencapsulated bibred bioactive compound with the mixture of CHITOSAN and Arabic gum will have higher encapsulation efficiency compared to using CHITOSAN and Arabic gum alone. Next, when conducted the antioxidant capacity is increased in encapsulated bibred bioactive compound compared to non-encapsulated bibred bioactive compound. And the last one, for thermal stability of the microencapsulated bibred sample, the percentage of bioactive compound in microencapsulated bibred is better than non-encapsulated bibred. In addition, the rate of bioavailability of microencapsulated bibred bioactive compound will also improve. For encapsulation, the study on microencapsulation bibred bioactive compound with CHITOSAN and Arabic gum by using spray drying method is achievable. Next, the microencapsulation will help to protect the bioactive compound in the bibred, as seen in the higher flavonoid and phenolic content in encapsulated bibred. The rate of bioavailability of bibred will also improve. The antioxidant capacity is higher in microencapsulated bibred compared to non-encapsulated bibred. And the last one, the microencapsulated bibred bioactive compound will have better endurance under accelerated condition, and since it is encapsulated with CHITOSAN and Arabic gum, it will improve the thermal stability of these substances. In here, I have included the Gantt chart for my bachelor degree project along the semester. And this is the Gantt chart for my bachelor degree project 2 that will be conducted in the next semester. That is all from me. Thank you for listening and have